All right, so the derivative from the algebraic viewpoint, this section is making the values that we estimated in the last section more exact. Okay, so that's the goal of this section. This is the ideal way you want to approach the derivative using the definition of derivative. The next few sections, you'll find a nicer way of actually computing the derivative using differentiation rules. It makes your life a lot easier, but to get there, we have to do it in a gradual way by first applying the definition. So here, recall that the derivative of f at x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So now in example 1, we want to find, or given f of x is equal to x squared minus 3, we want to, and given that a is equal to 1, we want to find f prime of a. So in other words, we want to find f prime of what? 1. Very good. So f prime of 1 is equal to the limit as h approaches 0 of f of 1 plus h minus f of 1. We can make the minus look separate because it is. Minus f of 1 all over h. Now that's equal to the limit. Remember, you write the limit until you evaluate. That's the limit as h approaches 0 of, we substitute in 1 plus h for x here. So we get 1 plus h quantity squared minus 3 minus the quantity, I'm going to put in parentheses now because we have two terms in f of x, minus f of 1, so we substitute in 1 here. So you have minus the quantity 1 squared minus 3. All of that over h. Now, that's equal to the limit as h approaches 0. Now, to find 1 plus h quantity squared, you have to use the FOIL method. So you get 1 plus 2h plus h squared minus 3. 1 squared is what? 1. 1 minus 3 is negative 2. So you're subtracting a negative 2, which means you're doing what? Plus 2. Very good. You're adding 2. All over h. Simplify the numerator. What do we get when we simplify the numerator? I can't hear you. Good, you get 2h plus h squared. So yes, your numbers do cancel out all over h because you have 3 minus 3. So that's 0. So you're left with 2h plus h squared over h. Your numerator has what in common? H. So remember, we write the limit until we actually evaluate. So that's the limit as h approaches 0 of h times the quantity 2 plus h all over h. What happens with those h's? They cancel out. Good. So this is equal to the limit as h approaches 0 of 2 plus h. And as h approaches 0, what is that equal to? So now you have to remember what we talked about whenever you were evaluating limits. When you evaluated limits in 10.3, as h approaches 0, what do you get? 2. Very good. So now you're connecting all of the ideas from before with this new idea of derivative. Does that make sense? If you have questions, ask. Okay? All right, let's keep it moving. So this is another problem. A little bit lengthier, but this is another problem. Okay? So we have a given f of x. It's not too long. given f of x equals 2 over x, let me move this down a little bit. Given f of x is equal to 2 over x and a is equal to 5, find f prime of a. Okay? What are we finding? Walk me through it. Come on. F prime of 5. Good. F prime of 5 equals what? The limit as h approaches 0. Say it again.
F 5 plus h minus f of 5
Over h. Very good. So we read this as the limit as h approaches 0 of f of 5 plus h minus f of 5 all over h. So this is equal to the limit as h approaches 0. What's f of 5 plus h? Good. 2 over 5 plus h. We're going to subtract what? 2/5. Good. And we're going to divide all of that by h. You got it. Okay? Good. So now what you can do, you can find a common denominator in your numerator. That would be 5 times 5 plus h. So this would be the limit as h approaches 0 of 2 times 5 over 5 times 5 plus h minus 2 times 5 plus h over 5 times 5 plus h. All of that divided by h. So what we did was we found the common denominator here in the numerator. It's 5 plus h times 5. So we put the 5 over 5 here, which is 1. So we don't change the equation from this. And here we put 5 plus h over 5 plus h here. Does that make sense? Okay. Now, dividing by h is the same thing as multiplying by 1 over h. So this is equal to the limit as h approaches 0 of 2 times 5 is what? 10. Good. So you have 10 minus the quantity 10 plus 2h all over 5 times 5 plus h. All of that times 1 over h. That's equal to the limit as h approaches 0 of 10 minus 10 minus 2h divided by 5 times 5 plus h, all of that times h. What happens in your numerator? Can't hear you? 10 minus 10 is 0. Good. 10 minus 10 is 0, so you're left with? Good. So that's equal to the limit. Remember, write the limit until you evaluate. The limit as h approaches 0 of negative 2h divided by 5 times 5 plus h times h. What happens now? The h's cancel. Good. So these h's cancel. And then you have, this is the limit as h approaches 0 of negative 2 divided by 5 times 5 plus h. As h approaches 0, what do you get? Very good. Negative 2 over 25. That's your derivative of that given function at 5. That's the derivative of f at 5. What questions do you have? Okay. Do you have questions? Okay, so let's go through our last example. If a stone is thrown down at 120 feet per second from a height of 1,000 feet, its height after t seconds is given by s equals 1,000 minus 120t minus 16t squared. Find its instantaneous velocity function and find its velocity at time t equals 3. When I say find its instantaneous velocity function, what am I asking you to find? Yes,
Isn't it like the?
he had his hand raised. Cooper.
Oh,
Go ahead.
The derivative
Talk loud.
I forget. Derivative of f.
We don't have F here.
What?
We don't have F here.
Derivative of t with respect to f for x.
There is no T and there is no there is no F and there is no T. What were you gonna say, Eli?
Wasn't it like just the derivative of speed versus time?
Say it again.
The derivative of like speed related to time?
S is the position. So it will be the derivative of your position with respect to time. Okay? So S remembers your position. Okay? So the instantaneous velocity function here would be S prime of t. So this is S prime of t. That's the first part. And then the finding the velocity at time t equals 3, that's finding S prime of 3. Okay? So S prime of t is equal to the limit as h approaches 0 of S of t plus h minus S of t all over h. Okay? So you take t plus h, you substitute it in where you see a t here. That will give you S of t plus h. So doing that, we have this is the limit as h approaches 0 of 1,000 minus 120 times the quantity t plus h minus 16 times the quantity t plus h. That's a t here. And then we're going to subtract from that S of t, which is just our function. 1,000 minus 120t minus 16t squared. And notice that we put that in parentheses because we have to distribute the negative. Did I leave something off? That's right. Good. That's absolutely correct. You're paying attention. Wonderful. So you have to finish writing. So that would be squared, right? And then you're subtracting the S of t, which is 1,000 minus 120t minus 16t squared. Good. And then we're going to take all of that and divide it by what? H. Good. Now you have to expand all of that. Now you have to expand all of that. So this is the limit as h approaches 0 of 1,000 minus 120t minus 120h minus 16t squared minus 32th minus 16h squared minus, distribute the negative. Now we distribute the negative to each term here. Minus 1,000 plus 120t plus 16t squared. All of that over h. You need me to explain some terms? Okay? So, simplifying, what happens to those 1000s? You have a 1000 here? They cancel, right, because you have minus 1000. The same with the 120Ts, very good. Anything else? The negative 16T squared and the positive 16T squared. Anything else? No. Right. You look here, all these terms have what in common? An H? I can't hear you.
I'm kind of like just like talking to myself. I think I got it.
That's good to talk it out, talk and see what's happening out loud, right? They all have an H. Factor it out. So we can write this as the limit as H approaches 0 of H times the quantity negative 120 minus 32T minus 16H all over H. Those H's cancel. So we have, this is the limit as H approaches 0 of negative 120 minus 32T minus 16H. No, because you factored out the H here.
Oh, yeah, sorry.
You factored out an H from there. Now as H approaches 0, what do we get? As H approaches 0, what is that? Talk loud.
Negative 120 minus 32T.
Very good. Negative 120 minus 32T. That means this is your instantaneous velocity function. That's the instantaneous velocity function. A lot of work, but that's your instantaneous velocity function. Okay? And then the second part says find its velocity at time t equals 3. So that means that we find s prime of 3. So that's equal to negative 120 minus 32 times 3. And that's going to give you what? Very good. Negative 216. And because we're talking about velocity, it is feet per second. This is the derivative. So now I suggest that you go through and work through the homework problems, do the applications of it, so you can become very familiar with it. Okay?